Hello and welcome to Algebra 1. We're starting a new unit, Systems of Equations. This is the first lesson, so here we go. This is solving linear systems by graphing, and really at this point you may be going, solving what now? How? What? What are you saying? And so let me explain a little more. Actually, no, let's do a warm-up and then I'll explain. So let's do some graphing, because we're going to be solving using graphing, so we better make sure we remember how to graph. We use slope-intercept form, if it's possible, to graph, because then it tells us that we have a certain slope and a certain y-intercept. And so we start with the y-intercept. We put that on the y-axis. So we'd put a dot here at 4, and then we use the slope to do our rise over our run. So since it's 2 over 3, that means that we need to go up 2 and write 3. Except hang on, we don't have enough room. Up 2 over 3 is about right here. So I guess we could make that dot off our graph and go ahead and draw our line. Or we could go the other direction. So when that happens, when you don't have enough room to easily make your graph keep going or your line keep going one direction, you go the other direction by switching both things. So now let's try going down 2 and left 3. And the reason that works is because if we go negative for both directions, 2 negatives make a positive. So it's still talking about positive 2/3, even though we're using down and left. So that'd put us over here. And then we'll draw our line. Easy peasy, lemon squeezy, all that jazz. So that's a reminder of how to graph. Now, here's the new thing we're doing. Systems of equations. What we've done up until this point with equations is either we've had one variable and we've been able to solve for that variable. So we might get something like an answer like x equals 2 in that situation. Or we have dealt with equations that had 2 variables, and what we've done with those is we've graphed them like what we did in the warm-up. But now we're going to introduce the idea of a system of equations. A system of equations is a group of equations. So that would mean that we have more than one equation. We are going to focus particularly on this, in this chapter, unit, whatever you want to call it, on solving linear, meaning these are all going to be lines, linear systems in 2 variables. So 2 variables, not 3, not 4. All of that's possible, but does get more complicated the more variables you have. So we're going to start off like we do constantly in math with the easiest possible situation and then build on our knowledge from there. There are actually a lot of ways that you can solve systems of equations, and in Algebra 1 we learned the 3 most basic ways. So that would be graphing, substitution, and elimination. There are other ways that you might encounter in Algebra 2 or pre-calculus or college algebra later on, but for now we stick with these 3. And so there's times where each of these would be the most helpful. I have a favorite method, and I think most people end up having a favorite method. I'm not going to tell you what my favorite method is because I want you to have a chance to decide for yourself. But we're also, after we go through each method, going to talk about how do we know which one's the best one to use in a situation. Because that's one of the reasons why we learn all 3 instead of just learning one or the best one or whatever you want to call it. Because we want to be able to make good decisions about what we're doing in math. So as we go over each one, though, you do need to do it that particular way to practice that way. This is one of those times where, yeah, you could get counted off for doing a problem the wrong way, but it's because you're being taught a specific skill. If you solve a question that asks you to graph without graphing it, you didn't really do the skill you were being assessed on. So I know that can be frustrating, but I think all 3 of these ways are definitely something that you are capable of. So let's see how do we do this. I have steps that I wrote at the end of this. So our first step, which isn't going to actually happen to us in this video, is that if you're trying to solve by graphing and your equations are not in y equals mx plus b, that's the first step. You want it to be y equals blah, 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 blah. Our second step is going to be to graph both equations on the same coordinate plane. And I do have a quick hint for you of something that might make things easier. You only need 2 points to make a line, but if we want to see where these intersect, the more points we make, especially on the first line, the better, because we don't know where they're going to intersect. We don't know if they'll intersect like to the right of the y-axis or to the left of the y-axis. So if we make dots both directions, then we won't have to go back later and try to figure out where those dots should have been. So I'll definitely show you what I mean by that in the course of these examples. So example 1, y equals 5x minus 4. So our y-intercept is negative 4. And our slope is 5, so this is 5 over 1. We go up 5, right 1, or down 5, left 1, but we don't have room for that. So here's our graph. There's not actually enough room to make more points. So in this case, the way these problems are designed is that in order for these to meet at a nice point and on this graph, there's really only one option of where they can meet. Spoiler alert. Now let's graph this other one. So we start at 3, and then we're going to go down 2, right 1. But when you realize that you've put a dot on top of a dot from the first line, you've basically figured out all that you need to from this line. Some students will not actually draw out both lines for some reason. And I assume that's partially laziness and partially because you're maybe just unhappy about how hard it is to make straight lines. But do please actually make both lines. In this case, our work for this problem is this graph, these two lines that we're showing where they intersect. Our answer is the point where they intersect. So this point right here, which is right 1 and up 1, we're going to write that as 1, 1. And in fact, all of our answers that we actually get an answer for systems, we write as a point x, y. So that should be something that you hopefully will get used to doing, is writing these answers as a point. Basically, in case this wasn't obvious, which it probably wasn't, when we're asked to solve a system of equations, one of the ways to think of it is we're being asked to find where the two lines intersect. So we did. They intersect at 1, 1. I would like to point out to you that 1, 1 looks like, I like to think of it as an owl face, but it could be a variety of animal faces if you just kind of picture that 1, 1 as eyes and a nose and like the outside of the face. So I thought you'd like to know about that. Let's look at another example. Example 2. Y equals negative 4 does not have an x in it, and so remember that y equals a number is a horizontal line. So since it says negative 4, it's a horizontal line at negative 4. You can make dots on all these points, or I think when it's a horizontal or a vertical line, I think it's easier to just tell where they intersect without having to make points, but for any other line, I recommend point. This other one is y equals 4x plus 4, so we're going to start at 4, go up 4, right 1, but we don't have room to do that, so we'll go down 4, left 1, and we haven't met our line yet, so we need to go down 4, left 1 again. There we go. We intersected here. So see how sometimes we have to make more points so that they intersect. Sometimes you have to go backwards to get them to intersect instead of forwards. It's a fun time. It's a puzzle sometimes. Negative 2, negative 4 is our answer for example 2. Example 3. So we've got y equals x plus 2 that we're going to graph. So start at 2. Remember that if there's not a number in front of x, there's a silent 1. So it'd be up 1 over 1. And so this is where if I make a bunch of dots now, I may not need all these dots, but I won't have to worry about going back later on and putting in more dots, which I personally am a fan of, not having to go back. The other one is at 4 and has a slope of negative 1, so that'd be down 1, right 1. So yeah, we didn't need all those dots, but we didn't have necessarily a way of knowing until we actually started graphing them. So these intersect at 1, 3. Remember that x is left and right and y is up and down. So there's our answer. Example 4. So at this point, maybe you've got the hang of this. I just realized I didn't check any of these, so I should probably show you how to check one of these. So we just basically take the point and we put it back in where x and y are, and check that we have true statements. So I'll try really hard to remember to do that on this one. The first equation starts at -1 and goes up 1 over 2. This is again is one where if I make more dots, for one thing, it helps me make straighter lines to make more dots. I talked about that whenever we when we first did graphing. And then also just it makes it easier to tell where they intersect. The other one starts at 2, -1/4. You can go down 1 and right 4, or you can go up 1 and left 4. Looks like down 1, right 4 is going to be the thing that helps us intersect here. So this intersects at 4, 1. So what we do to check is we'd put this in as x and y in both equations. So 1 equals 1/2 times 4 minus 1. Well, 1/2 of 4 is 2. 2 minus 1 is 1. So works in the first one. 1 equals -1/4 times 4 plus 2. This part becomes -1. -1 plus 2 is 1. So it works out. That's a helpful thing to be able to do, especially if you're taking a test or a quiz where you might feel more pressure to get things right than if it's just on practice or homework. So that's how you do it, is you plug it back in. Here are those steps that we have. So you solve for y if it's not solved for y. Graph both equations, draw as many points both directions as possible, at least on the first line. And then find where the lines cross, that's the solution. So you can check your answer by plugging the solution into both equations. And it's a pretty great time. Hopefully this was pretty straightforward. And definitely leave me a comment if you have any questions on how to do this. Thanks so much for watching. Hopefully you're subscribed already. Give me a like on the video because it's a fun time to do that. And I'll see you in the next video. Thanks.